Hello, welcome. Today let's try to solve another Leetcode problem, 2799, called complete subarrays in an array. So we are having an array nums. So inside of the nums, we're gonna find the subarray. But the subarray should meet some conditions. So the number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. So what is the number of distinct elements in the whole array? So for this example, it's gonna be 1, 2, 3. So for the subarray, it's gonna be 1, 3, 1, 2. So there are three unique numbers, and we also have 1, 3, 1, 2, 2, 3, 1, 2, and 3, 1, 2, 2. Yeah, but how can we find such solutions? Because the subarray is continuous, so this means we can use the sliding window to find. So for example, from the left to the right until we find a sliding window, so the sliding window will go to 1, 3, 1, 2. Up to here, we found a solution. But at this position, if the right pointer goes to the right, goes to this position too, it is also a result. So that is why, while we are go to the sliding window, go from 1 to 3, 1, 2, we can directly get the result. It's gonna be 2. So the final result will be n. N is the length of nums. It is 5 minus the index at the right pointer. So the right pointer will be 3. So 5 minus 3 is gonna be 2. So up to here we find a 2 result. Now we're gonna shift the left pointer. So the left pointer will be shifted to 3, 1, 2. As you can see that if it shifted to one position, it goes to 3, 1, 2. We still have two possible results. It's gonna be 3, 1, 2, 3, 1, 2, 2. And then what are we gonna do? We're gonna shift to the left pointer, goes to 1, 2. And then we don't have an answer. Now we're gonna shift to the right pointer, so the right pointer will be 1, 2, 2. But for this 1, 2, 2, there's no possible result. Now we're gonna try to shift to the next right pointer, so it will go out of the boundary and it will stop the loop. So there will be 4 answers. Now let's try to solve it. So I'm gonna have a capital L. It would be the size of the unique characters in the whole array. So it's gonna be the length of the set. We're gonna use a set of nums. Up to now, the time complexity is on because we used a set. Now what are we gonna do? We're gonna use the sliding window. So for the sliding window, the template code is L result. So the L is 0 and the result is also 0. And I also needed to prepare a counter. So because I'm gonna use the counter to check how many unique characters inside my sliding window. Now let's try to solve it. So for array in enumerate nums, so I'm gonna prepare another variable. It's gonna be n, which is the length of the nums. Now I'm gonna put it inside the counter. So cv should plus equal to 1. Now I'm going to check it because the sliding window is not fixed. So I'm gonna check if there are 3 unique characters. So length of the counter, if it is equal to 3, I'm gonna get the result. So the result would plus equal to n minus the right pointer. Now I need to update the left pointer, but before I update it, I need to check the counter. So C with nums L should minus equal to 1. Now C nums L might be 0. If it is 0, I have to pop it out. So C dot pop nums L. So this is my template of sliding window. You can also use other tricks, but for me, I'm gonna pop it out. And in this way, I can check how many unique characters inside my sliding window. I can use the counter to check. And this is not 3, and this is L. It's gonna be how many unique characters. And finally, I just need to return the result. This is the entire code. As you can see, it is not so difficult. Everything is just a template. So there are tricks about this kind of a sliding window problem. Now let me just submit it. As you can see, it works. Now let me submit it to check all the testing cases. As you can see, it's pretty fast, nearly 100%. It means the time complexity is still O(n), because it is a sliding window. The right pointer will always go to the right, and the left pointer will also always go to the right. So the maximum the time complexity will O 2 times n, so it is O(n). Thank you for watching, see you next time.